This meeting is being
Okay, so let us continue our study in set theory. So if you remember last time I started talking about the algebra of sets, we learned the notion of the complement of a set. So if you remember, here we defined the complement of a set to be the set whose elements are coming from the universal set, but they are not in the original set itself. And then we also learned some properties of this action of taking complement of a set. We learned that the complement of the universal set is the empty set. The complement of the empty set is the universal set. And if I take the complement of a complement, then it becomes the original set. One important thing was that if A is a subset of B, and if I want to take complement from both of them, I'm not allowed to keep the direction. I need to also interchange the places where the sets are appearing in this relation. So you see that A is a subset of B. Then I wrote B's complement is a subset of A complement. This also was shown by this Venn diagram. We also had the complete proof here. And then we started an operation. This is the first operation that we learned to do between two sets, and that's called the union of sets. If I have two sets, the union of A with B is denoted by this symbol, and I told you that this is more or less similar to U, but when I want to use U for the universal set, I just put these small dashes on top so to distinguish it with the union symbol. Okay, so the union of two sets is defined as the set of all elements in the universal set. So this is my universal set, so that the elements are either in A or in B or in both. And I talked about this, that always or in mathematics is the logical or, it's not the exclusive or, it's inclusive. So if this is true, this is false, we say that this is true. If this is false, this is true. Again, we say that this statement is true. And if even both of them are true, then again we say that this statement is true. So if I want to give you an idea what is a union of those two sets, you can say that, okay, if this is my set A, this is my set B, this part is only that part which is only in A, this part is that part which is only in B. They should be included in the union, but this part which is also in both should be also included. So the whole union, if you want to draw the border of the union, would be this. This would be the union of these two sets. And then I told you that if I have two sets, if I want to determine A union B, I would do this. I would write all the elements in the first one without thinking, but I need to append these elements to this set. But when I reach to a repeated element, I do not repeat it. So I just wrote 1, 3, and -2 here. But now I'm going to append this, but when I want to put 3 here, I see that 3 is already done, is already there, so I ignore that and I go to the next one, and that is the union. Okay? Now today we want to talk a little bit of examples and properties here. Okay, so let me start with an example. Example. So let me write true or false, yes? So number one, these are the standard sets. For example, let me write, if I have the set of integers, which in mathematics is denoted by this symbol, if I union it with the set of rational numbers, I would write it as the set of the integers. Yes. So we want to say it is true or false. Number two, you can think about it when I come back to the solution. Yes. Okay. So I think this is a very simple exercise. So let us do it quickly. So which one of them is true or which one is false? So what is your idea about the first one? This is the set of all integers, 0, positive ones, and negative ones, -2, -3, 0, 1, 2, 3. These are the numbers that you expect here in Z, but you know what is Q. Q is the set of rational numbers, the numbers that can be written in the form of a fraction where the numerator is an integer, the denominator is also an integer, but the denominator is not equal to 0. Yes? Okay, now do you think this is a correct statement or a false statement, true or false?
False.
False.
Yeah, that is clearly false, yes. Because for example, I am telling you that this union is going to be Z. If I ask you, do you think that 2 over 3 is in this union? Your answer is yes, even though 2 over 3 is not in Z, but 2 over 3 is in Q. If an element is one of these sets, then definitely it is also in the union. So it means that if I ask you at the end, do you believe that 2/3 is an element of this set? You would say yes. But now if I ask you, do you believe that 2 over 3 is an element of this set? You would say no. So this equality cannot hold because at least I found an example of an element which is inside this set but not in that set. They cannot be equal. So yes, that is false. So what about the next statement?
It's true.
Yeah, it is true actually. We will come back to the proof of this later a little bit. So if I have two sets, A and B, and I know one of them is the subset of the other one, we will see that A union B is equal to the bigger set. Okay, and then you know that Z is a subset of Q. When I add them, actually I am not adding anything new to Q. Yes, because do you remember? First of all, do you believe that Z is a subset of Q? Yes, because any number, any integer, for example, say A, can also be viewed as A over 1. It can be written as a fraction. And then the numerator and denominators are coming from the set of integers, and the denominator is not equal to 1. So any integer is indeed a rational number. And if I want to union them, so I will write all these elements and then I want to append the elements of this to this, but all of them have already been written. So there is nothing new that I can add. So this one is true. What about the other one? N union Q complement is equal to N.
False.
That's also false, yes. Why that is false? For example, I need to cook up a counter example. I need to show there is an element which is on the left-hand side and it is not on the right-hand side or the other way around.
The
Yes,
square root
can
of
you
minus
cook
y.
up an example?
The imaginary number y.
Let us work. So let me be more precise. So I would say let R be the universal set.
The irregular number pi.
Yes, for example, pi is a good example because if I ask you, the most famous one might be is not pi. Let me just use a square, but pi is also okay. But let me use a square root of 2. Yes, square root of 2 is definitely not in n. Square root of 2 is not an integer. Is not a natural number. But do you think that square root of 2 belongs to this set? I would say yes. What is the Q complement, by the way? The complement of the set of all rational numbers is an irrational number. Yes, is the set of irrational numbers. And a square root of 2 is a famous example of being of an irrational number. So a square root of 2 is an irrational number. Irrational number, the set of irrational number is equal to the Q complement. So a square root of 2 belongs to this part. When it belongs to this part, it also belongs to the whole union. So a square root of 2 belongs to this one, but does not belong to this one. So this is why this statement should be a false statement. What about the other one? Number
It's
4.
false.
It is also false, exactly. Why? Can you give an example here?
1 is a natural number, but it's not an irrational number.
Yeah, exactly. So 1 is a natural number. 1 is a natural number. So 1 belongs to this part. When 1 belongs to this part, definitely it also belongs to the union, because when we union two sets, we are appending the elements, yes? So if 1 is already there, it will remain in the union as well, okay? So at the end, 1 belongs to this, but 1 does not belong to the irrational number. So this is why that's also false. So what about this one?
Also false.
Are you sure about this one now?
It's true.
I'm thinking. Maybe not.
Yeah, it is true here, because I told you that let us have this R be the universal set. So I is just Q complement, and then if I union a set with its complement, it becomes the universal set. I will talk about that. So this is also true. Yes. I don't know. Let me give you another example. So example. So let A be this set. The empty set and the singleton containing the empty set, and
Mr.
B.
Babak,
Yes.
Pi. That's a real number, but
Yes.
it isn't a Q, is it? It's not a rational.
No, it is not in Q, but it is in I. Pi.
Oh, it's Wait, is pi is irrational?
Pi is irrational. Yes.
Oh, okay. Thank you.
No, because I thought that because you also gave an example of square root pi in for this. So it means that you need, this means irrational. When you say Q complement, it means that whatever we have except rational. So it becomes irrational. So when you say pi is a counter example for this, I accepted that, but I told you, let us start with the square root of 2. Yes, pi is an irrational number, remember. EE, the Euler number, is also irrational. These two fundamental constants of mathematics, both of them are irrational numbers.
I accidentally thought that unreal numbers were irrational numbers, but I mixed them up. That's why.
Yeah, okay. So now let me write B. B is this set. So write A union B. So write down A union B. So what should we do? If I want to union A union B, then I would write the elements of the first set. I told you that I always do this. I will write all the elements in the first set. There are only 2 elements in the first set. One of them is this empty set, and the other one is the singleton consisting of the empty set. So it means that if I want to write the union of this set with any other set, I don't think first, I just write all of them. But then I go to the second set. The second set also contains 2 elements. One element is this as a package, and this one is another one. So I need to start adding them here. But when I want to add this one here, I will see that this is the repetition of one thing which is happening before, so I don't add it. And then what I do, I just go and add the other one. Can I add this one? Yes, because this is a new thing, even though it is made up from these 2, but this is not this one, so I need to add it. So sorry, this is not this one, nor this one. So I have to add it, and then I close this. So that would be the answer to the union of A and B for this example. Okay, so let me write a true-false statement exercise, and then we can go to the other part of this lesson. So example.
Bracket.
Yes.
I think you forgot to write one bracket in the question.
In the yes,
Example.
thank you very much. In the question itself, you mean?
Yeah.
Okay, thank you very much. Yes, you are right. Thank you. Okay, so we go to the other example. So true or false? A and B are sets. So let me write them quickly. So if I have X in A union B, does this imply that X belongs to A or X belongs to B? If I go to number 2, you can check if this is true or false with yourself. So, okay, so let me do the, yeah, that's also correct. Yeah, it was better that you can write something on the right-hand side. So let me change the question. So, write the right-hand side. Write a statement on the right-hand side. On the right-hand side so that the implication is true. Yeah, this is a better exercise. Okay, so I will write them and then you can think about them. Number 2, number 3. Yeah, this is very simple, but I want to make sure that you know about it. So number 4. Okay, so this lesson is about union. So try to write something on the right-hand side related to the union of two sets, say A and B. So the question is not 100% clear what I mean, because might be you can write different things to make this clear, to make this right, but try to work with the union of two sets if possible. So for example, here, I hope that you agree that this should be the statement that I put here. That's exactly the definition of the union of two sets. When you say an element is in the union of two sets, immediately you can conclude that either this element is in the first set or in the second set, but because or in mathematics is a logical or, it means that or both, yes? So when you say this belongs to A union B, it means that this is in the first one, not in the second one, or in the second one, not in the first one, or even in both of them. Okay, now can you translate this one? What should I write? When someone tells you that, I looked inside union, I saw that X does not belong to the union A and B. Okay, union of A with B. So what you can conclude?
That X is not in A and X is not in B.
Exactly. So that is the right conclusion. So let me write this with green. So X does not belong to A, and it's very important to write and. X does not belong to B. Okay. So what can I write for the next one?
X belongs to the union of A and B.
Exactly. Exactly. And then what can I write for the next one? Can I also conclude that in this case, X belongs to the union, even though I know X does not belong to A?
Yes.
Yes, because I know that X belongs to B, so who cares about the other set? X definitely belongs to the union. The next thing is also the same. X belongs to A, so I don't need to be worried about if X belongs to B or not. Definitely X belongs to the union. And if someone tells me that X is neither in A nor in B, what can I conclude about that X regarding to the union?
That it does not belong to it.
It does not, yes, exactly. It does not belong to the union. I think these are simple things, so you can let me be consistent and write this in green as well. Okay, so this is good. Now let us go to a theorem. So I think it would be a good idea if I go to the next page and write the theorem. Okay, so let me see if this is a good idea. Yes. This theorem again is a spread. Some of them are mentioned in the exercises. So I want to have them in one place. So theorem, let A, B, and C be sets, and let, to emphasize again, let this U be the universal set. Then I will have these properties. So number one, what happens if I union A with the empty set? So what would be the answer?
A.
A, yes. So from now on, you need to remember, if I union any set with the empty set, the answer is the set itself. So we say that the empty set plays the role of the identity of this operation. Identity of an operation is an element if exists, so that if you do that operation between any element of this set that you are talking with that element, it does not affect the result. It does not affect this element. So this is a property. Number two, we have another extreme. This I want you to know. So what happens if I union a set with the unions, with the universal set? Then what will happen?
You get the universal set.
Yeah, clear. I hope that you just refer to your intuition and answer these, okay? Of course, mathematically, you can also prove them, but they are simple, so I just want you to know. Another thing that is also very simple, but it is good to know, is that doesn't matter if you union a set with itself. So what would be the answer if I union a set with itself?
You get it A.
You get the same set, yes, because you were supposed to write the elements of the first set, and then you need to append the elements of the second set if they are not repeated already. But because these two sets are the same, if I come here, every element I have already written it here. So I don't need to append anything, so it means that this set becomes the set A. So the union of a set with itself is always equal to A. Okay, number four. So let me write here. So number four, it's commutative. So it doesn't matter if I union A with B or union B with A. It doesn't matter. The answer would be the same because the order of the elements in a set is not important. Number five is associativity. Associativity means that if I have three sets to be unioned, okay, it doesn't matter if I do this one first, and when I find the answer, then I union A with the answer, or if you prefer, you can do the first pair first, and then after you found the answer, you do it with the third one. This is also a very important property. So what does it mean? It means that you really don't need, this expression is not ambiguous. Let me talk a little bit about this. So you might take this for granted, but you need to be careful. This is not always the case. So let me write with something and then I will clean it, okay? For example, if I say 2 plus 3 plus 4, you don't complain. You will answer this, because even though I have two operations of addition, but it doesn't matter which I prioritize. Yes, I can do this one first, 2 plus 3, and then add it to 4. This becomes 5 plus 4, and the answer is 9. I can also do the other one first and then do it with 2. The answer, of course, the operation is a little bit different in order, but the final answers are the same. The reason that you don't care about putting a pair of brackets in a string of additions is because addition is associative operation, is an associative operation. Okay? But if I ask you the same question with division, then I have to be careful. Okay? Because the answers are different. So if I choose to do this one first and then this one, the answer 2 divided by 3 is 2/3, and then divided by 4. So if I do that, it becomes 2/3 multiplied by 1/4, and the answer would be 2/12, or 1/6. But if I choose to do the second division first, the answer would be 2 times 3/4, because 3 divided by 4 is 3/4. And if I want to do this, I would write 2 and turn division to multiplication, and I write the reciprocal of 3/4, and the answer would be 8/3. And then you see that the answers are not the same. So I would say that here, putting or ignoring pair of brackets is not important, because the addition operation is associative. But here I cannot just ask you to give me the answer to this string of numbers and operations, because it depends to the order that you prioritize one of these divisions. If you prioritize this, then the answer would be 1/6. But if you prioritize this operation, the answer would be 8/3, and the answers are no longer equal. So it is very important. When we say an operation is associative, it's a very relief. Yes, you do actually, it's a big relief, because we don't need to care about being very careful to group the elements in a proper way. There is no proper way. Whatever you do, you will get the final answer the same. But if an operation is not associative, you have to put the pair of brackets to prioritize which one, to prioritize the operation involved, so to be clear to your audience what you exactly mean. So this tells you that union operation for sets is associative. So when you have a bunch of sets that you are unioning them, it doesn't matter how you group them, the answers would be the same. Any questions? Because I want to erase this. Okay. This is also something that I want you to know. Number 6, I think it's also very clear, but very important. If I union a set with its own complement, what do you expect to get?
The universal set.
The universal set. So that would be the universal set. The union of any set with its own complement becomes the universal set. So one thing that I want you to know, actually these are very simple ones, but let me just write them. So if I have, so number 7, if I have two sets, I union them, can I say that A is a subset of the union? Yes?
Yes.
Yes.
Yeah, so yeah, that is very important to know, that if you have one set, any set, and then you union it with an arbitrary set, even if you don't know what that set is, definitely your original set is a subset of that union. This is also true for B, of course. It doesn't matter, there is no difference between B and A here. So I can say that B is also a subset of A union B. Okay. So number 8, that is also good to know that if A is a subset of B, not just two arbitrary sets, one set is a subset of the other one. Can you tell me what happens if I union these two sets?
It will be equal to just B.
Yes, exactly. That's a very good. So this implies that the union becomes the bigger set. Yes? And the other way around is also true. So let me write this arrow in the double. So that is a little bit non-trivial. So if the union of two sets happens to be one of those, it means that the other set is the subset of this answer. So I will talk a little bit about that. And then finally, this is also good to know, number 9. If I tell you that I should have written A, B, and C, and D, but okay, I will complete it. If I have A subset of B, and C is a subset of another set D, what happens if I union A with C and if I union B with D? What can I conclude about these two new sets?
They're a subset of.
Yeah, again, this is a
union of B
subset.
and D.
They are not hard to understand, yes? So if A is a subset of B, C is also a subset of D, I can union them side by side. I can say that A union C remains the subset of if I do the same thing with the right-hand sides B and D. So in principle, if I want to make my theorem correctly, I need to write, let me just write it a little bit smaller, C and D. Oops. So C and D. B sets. Okay, so these are the properties of the union I want you to know. But let me discuss, because I want to discuss about this one a little bit. So let us have a proof for that one. So number 8. So because this arrow is double-sided, this is actually not one problem, it's two problems. So I would say A is a subset of B if and only if A union B is equal to B. Okay, so let us first prove this direction from the left-hand side to the right-hand side for this arrow, for this direction of the arrow. So my assumption is that we know that A is a subset of B. We prove that A union B is equal to B. Okay? To prove A union B is equal to B, do you remember what I should do? If I want to show two sets are equal, there is a standard way. Let me refresh your memory if I have it here somewhere. Yes, before that even. Here. This is one of the notes from the previous lecture, yes? So if I want to show that two sets are equal, the standard way of doing this is once show that the left-hand side is a subset of the other side, and the other time you need to show that the right-hand side is a subset of the left-hand side. If you can show these two, then this will imply that these two sets are equal. So this remark is very important, even though it seems trivial. But whenever you want to show two sets are equal, you need to do it in two steps. First, show that the left-hand side is a subset of the right-hand side, and then show once more, do this for the right-hand side is a subset of the left-hand side. Okay, now let us go back to our lesson today here. So here we prove that A union B is equal to B. To prove A union B is equal to B, we have to show that A union B is a subset of B. And let me write it the other way around. We need to show that B is a subset of A union B. So which is true based on number 7. Assuming that we have actually proven number 7. And A union B is a subset of B, which is not trivial, because in general, A union B is bigger than B. But we want to show that for this particular case, under this condition, A union B is also a subset of B, if I have this condition. Any questions so far? Is that clear what we are doing?
Yes.
Okay, so now tell me, if I want to show that this one is a subset of B, what should I do? I should show that any element in the left-hand side is also in the right-hand side. Okay, so I'm explaining everything. So to show this, to show the ladder, we let X be an element of A union B. We show that X also belongs to B. Okay, so let us start. So you are saying that X belongs to A union B. What is the consequence by definition of the union? This means that X is either in A or X is in B. But I want to show that definitely this happens. Of course, if this part happens, this is guaranteed. But you see that still there is no guarantee for exactly this one, because when you say that X belongs to A union B, you conclude that either X belongs to A or X belongs to B. Okay, but how can I continue?
Well, we know that A is a subset of B, so we know that every...
Exactly. We know that A is a subset of B. Okay, so even if this case is happening, I don't have any problem. If you say that X belongs to A, you are also telling me that A is a subset of B. So here I can conclude that X belongs to B. So if X belongs to B, I am done. If X belongs to A, because of this assumption, again, X belongs to B. So at the end, whatever happens, X belongs to B. And then I am done. Is that understandable? Okay, this is one part of the proof, but the other part of the proof is also, we need to do it somehow. Okay, so what happens if I want to go in this direction? What is the meaning of going in this direction? It means that now my assumption is that the union of A and B is equal to B. I want to conclude that this is indeed the case, that this set is a subset of that one. Okay, so that is the meaning. So here we assume that, so we know that in this case, X, we know that A union B is B. We show that A is a subset of B. Okay, do you have any idea? Okay, so let me assume that this is not the case. Okay, so assume that this is not the case. And A is not a subset of B. So you see, I have this assumption. I want to prove my claim that under this condition, you have to admit that this is also the case. If you say no, it means that A is not a subset of B. Let us see what happens if we assume this is the case. Okay, therefore, what is the consequence of this? I would say, therefore, there is an element X such that, can you complete this sentence? If A is not a subset of B, then what does it mean? It means that there is an element X such that what?
In B that it does not belong, in A that it does not belong to B.
Yes, there exists an element X which belongs to A and X does not belong to B. Do you agree? This is the meaning of not being a subset. Okay, now you are telling me that X does not belong to B, and you are also telling me that A union B is B. Then, of course, I can immediately conclude, because these two sets are the same sets, and you are telling me that X does not belong to the right-hand side set, I immediately conclude that this X does not belong to the left-hand side set either, because they are the same sets. Okay, but can you tell me what would be the consequence of this statement regarding the X and A?
They are contradictory.
What do you mean? I mean, what can I conclude? X belongs to A, or X doesn't belong to A, or it is not clear?
They cannot both be true at the same time.
I know that these two cannot be the same at the same time, but what I want to write, can I write X doesn't belong to A, or I cannot?
Yes, you can do that.
Yes, that's my question. So you can write X does not belong to A. Do you understand why? Because if X belongs to A, definitely X also belongs to the union. When you say that X does not belong to the union, I am allowed to conclude that X does not belong to A. Of course, I can also conclude X does not belong to B, but I don't need it. I already know about the X and B. Then it means that X does not belong to A. But this is contradiction, because now you are telling me that X belongs to A, and then I have to also admit that simultaneously X does not belong to A. This happens because of this false assumption. So this is a false assumption, so its negation, this one should be true. Okay, this contradicts X belongs to A. Therefore, A is not a subset of B is false, and A is a subset of B is then true. And now we are done. Okay, so this set theory is a little bit abstract if you really want to write these things, but this is the way that you need to understand and write. I don't think it's very hard, but it is a little bit unusual for high school. So yeah. Is there something that you don't understand? Okay. So from now on, this is important to know, to understand how to interpret this. If someone tell you that I have two sets, I know one of them is a subset of the other one. If you want to conclude something about the union of those, you immediately answer the answer is the bigger one. On the other hand, if someone tells you that the union of two sets happens to be one of those, then you immediately, if you want to, you can conclude that the other set is the subset of the answer. This is the content of number 8. Okay, so these are the properties of these sets. So let us do some exercises here. If I have enough space, no. So let me go to the next page. Example. So if you remember, I told you that this is the algebra of sets, and the algebra is always useful to simplify expressions. So when you are learning these rules, you in principle can simplify expressions involving sets. Okay, so let me just give an example of this type. Simplify as much as possible. So number 1, for example, A union the universal set complement. So let us do it together one by one. So how should I proceed here? I think this is one of those properties that actually oh, okay, I wrote it. I thought that I have forgotten. So you see, this will help you.
Isn't that just the empty set?
No, not empty set.
But
is it? Yes.
Because...
So let me see if I have. Yeah, that's empty set. Thank you. How should I? But write it in 2 steps. The first step. So this is what I want to make sure that you don't do it. Don't write A complement union U complement for some reasons. Okay. This pair of brackets means that the priority is given to this union. So you have to do the union first. And then when you found the answer, you take the complement. Yes, you are right. That was my mistake. So A union U is U. So what I have written here is the answer to this part. But on top of that, I see a complement there. So I put a complement here. But then I have this in the previous lesson. U complement is nothing except the empty set. So this is algebra of sets, you see, because what I am doing, I am simplifying this expression without knowing anything about the elements inside the set A. It is irrelevant. It doesn't matter what is inside A. The answer to this calculation is always the empty set. Okay, number 2. Let me write one more thing. So what is your opinion about this, by the way? I write the union, the universal set union by union of a bunch of sets, for example. So what do you think would be the answer to this?
Can I answer?
Yeah, you can. Whatever.
I think it's the universal set.
Yeah, it's the universal set. So you shouldn't be fooled by the complexity here. Whatever here is just one set. Who cares? I can call it, I don't know, I can call it curly A. This is just one set. Then I have the union of the universal set with this curly A. Then what happens? Who cares about this? When I want to union it with the universal set, we have the rule. The union of every set with the universal set is just the universal set. So this is the answer. It becomes simply the universal set. As simple as that. So number 3. Let me see how many ones are there. Yeah, I can write it here. So number 3. What do you think about this situation? I have a set B, and then I have the union it with the empty set, and then I complement it, and then I union it with B.
Is it B?
No.
Oh yeah.
Is it U?
It is U, yes, the universal set. Why? Because, be careful, you are not allowed to take this complement here and here. This pair of brackets prioritize. You see there are two union operations. But this pair of brackets prioritize this union over that union. And then after that, I need to apply the complement. And then when everything here is found, then I can union this one and that one. So let us do it in steps. What is the union between B and empty set? This is one property. The union of every set with the empty set becomes the set itself. So this becomes B itself. But on top of this, I have the complement. So it becomes complement, and then I union it with B. Yes? But what is the result? The complement of a set union with the set itself is also another property we discussed about. What is the answer? As you said, is U. Okay? So what do you think about the last one here, number 4? So let me write it in this form. A union, A complement, union, the empty set, and then complement. So what would be the answer? We need to do it step by step, yes?
Is it the empty set?
Yes, thank you. That's the empty set. So what should we do? We need to prioritize it. So we have this pair of brackets. Inside the pair of brackets, I have two unions. But because this union is inside another pair of brackets, the priority is with this one. So what I do, I can do it in this way. So I can write, I will keep A and then union. But what is the answer of this? The union of any set with the empty set is the set itself. So it becomes A complement. And then I have another complement on top of that. But then again, I have a pair of brackets, so this union has to be done first. So, but we know that what is A union with its own complement? It is the universal set. But on top of the universal set, we have another complement left, but we know that the universal set complement is the empty set. So the answer to this is empty. Is that understandable? Good. Let me make it a little bit harder. So example, let A and B be sets such that we know that A, we don't know A is a subset of B or not, but we know that A is a subset of B complement. Simplify this expression as much as possible. A complement union with A complement union with B, then complement, then union, A union B complement, complement. Simplify this as much as possible. Okay, so I want to pause the video a little bit. I want to give you time to think about it. Okay? So where do you start from?
I concluded that since A is a subset of B complement, I could conclude that B is a subset of A complement.
Excellent. Then?
And then I, in the first bracket, I replaced A complement union B with A complement. And
Very
then in
good,
the
very good.
second
Thank you. Thank you
Yes.
very much. That's a very nice understanding of what's going on. Thank you. So we want to simplify this. Okay, so here, for example, if I want to be a little bit pedagogic, so here we have 3 of these kinds of sets. Let me start with this one. I don't need to manipulate this. I can just immediately answer that. Okay, so I would say that you are telling me that A is a subset of B complement. I told you just right now, if you know something is a subset of another set, if you union them, you can immediately give the answer. The answer is the bigger one. This we learned, and we talked about the proof as well. Yes? Now you are telling me that this is a subset of this one. So this means that if I union them, the answer becomes the bigger one. Okay, bigger in quotation mark, of course. Okay, so that is exactly what I want to write here. So this means that A union B complement is equal to the bigger one, which is the B complement. Okay, so far so good. When I go here, unfortunately, complement is on top of A and B. So I need to know if I want to proceed, might be one way is to understand which one is bigger in quotation mark than the other one. But you are giving me only the information for A and B complement. But if you remember a previous lesson that I just refreshed your memory in the beginning, if this is the subset of this one, you can immediately write, oh, sorry. If this one is a subset of this one, you can immediately write the complement on the right-hand side of the right-hand side is a subset of the complement of the left-hand side. This is what we'll learn in the previous lesson. Now you are telling me that A is a subset of B complement. So what I can do, I want to take complements from both sides of this relation. But if you know the lesson, you need to interchange the places of these two. Okay, so this is what I want you to understand. Everyone happy with this? Okay. And then we have another rule. Do you remember? Complement of the complement is the set itself. So this implies that B is a subset of A complement. And now again, I am telling you what happens if I union these two. Okay, I know that this set is a subset of this one, and now I am unioning them. The answer becomes this one, the bigger one. Okay, so therefore, the question mark is equal to. In the question mark, I have A complement, so I don't know what to do with that, so I have to write it. And then union, instead of this inside the pair of brackets, you see I can put A complement, but I have another complement on top of that. So it becomes A complement, complement. And then union, if I go here, the answer is B complement, but I have another complement on top of that. So it becomes B complement, complement. If you want to simplify this, it becomes A complement, but complement of complement is the set. So that one also becomes the same. But if I want to be very strict, you need to write everything. So you see I have two unions, but we know that union is associative. So I can group the first two together, and then I will have the third one. But if I ask you, what is this one? You know the answer. So the answer is U, and union with the set B. But when I want to union a set with the universal set, the answer is the universal. So whatever A and B are, this calculation is, this set is always equal to the universal set. It doesn't matter what are the elements of the set. Okay, any questions? So let me give you another example. That is also good to write it down here. So example, So if A is a subset of B, B is a subset of C, and C is a subset of D. Simplify A union B as A union C union D union B as much as possible. Okay, so what we can do here, we have 4 sets. We don't know the elements of those sets, but we know that this relation holds among those sets. And then another set with 2 pairs of brackets and union operations is given to us. We are supposed to simplify this as much as possible only with these pieces of information. You can do it, I don't know, in different ways. It depends to you. But let me, for example, if I want to do this, let me do it in this way because I want to mention other properties as well. So my question mark is this. Okay, first of all, I can group them. So because all of them are unions, and we know that the union is commutative and associative. Commutative, it means that if you want to interchange the places of two sets, you can do that. Associative, it means that you can group them in different groups. The answer would be the same. Here, I have a relation between A and B. I also have a relation between C and D. So it might motivate me to regroup it. Okay, so I can write A union B together and then union C union D. I want you to remember that I am using commutativity and associativity. Otherwise, I was not able to write this. So usually, because these are always they are taken for granted, but I want you to understand, if this operation was not commutative and associative, we were not able to write this. But now we can. But now, if I ask you what is the answer for the first pair of brackets, you can immediately answer because I have told you that A is a subset of B, so the union between these two is the bigger set, which is B. And I have also told you that C is the subset of D, so the union of these two sets is the bigger set, in this case D. So the first one is B, the first one is B union, the second one is D. Should I stop here or I still can simplify more?
You can simplify more.
How? Because there is not a relation between B and D directly given in the problem, but can I conclude something for B and D?
That B is a subset of D, and therefore this can be simplified to D.
So why do you say that B is a subset of D? Because if you remember, the subset relation is transitive. Do you remember? So we know that, but we know that, let me write, you are right. But we know that because you are telling me B is a subset of C and also telling me that C is a subset of D, and then I know that the subset relation is transitive, I can conclude that B is also a subset of D. But now that you are telling me that B is a subset of D, instead of B union D, I can write a bigger set, which is D. Yes? So then it means that final question mark is equal to the set D, and it is clear that I cannot simplify it more than that. So if I have this relation, I really don't need to care about all of them. The answer is always D, the bigger one in total, yes? That's a good intuition to have in back of your head. If you can compare the sets based on this subset relation, if you are unioning them, the answer to the union is always the bigger one. bigger always in the quotation mark. Okay, is that clear? Okay, so I think we have a little bit of time. I can at least start another operation. That the second operation that we want to talk between sets is called intersection. Okay, so let me write intersection of two sets. Yes. Okay, so let me write the definition. Let A and B be sets. The intersection of A with B is denoted by the symbol that we use is A, and then we put this thing in the other way around. So you should be careful not to confuse between the union. Union is something similar to the universal set. Intersection is the other way around. It's denoted by this, and it is defined by A intersection B is the set of all elements, of course, in the universal set, but such that X is in the first one and the second one. Yes, this means and. So it means that we are actually caring about the common parts. What is common between A and B? That is called the intersection. Yes, for example, if I want to give you a feeling using the diagram, Venn diagram, if this is my Venn diagram, and then if this is one of my sets A, and this is the other set, for example, B, and then this part is the union. I don't know if this works in this way. Yes, this part that you see, sorry, is the intersection, not union. Yes, so this part which is in both of them is called the intersection. A intersection with B. So the elements that are simultaneously in A and B, that is called the intersection of two sets. Yes. So very simple examples. Let me just give an example, and then we are more or less done. So example. So here we have A equals to, for example, 2, 3, 5, minus 2. And then we have B equals to square root of 3, 3, 2, minus 1, 5. Then, what is the intersection of A and B? This is an intersection of A with B, but it is clear that there is no difference between the intersection of A with B and the other way around. So this means also that the intersection is also a commutative operation. Yes. So here, what is the intersection? 2 is here and here, so I will write it. And then 3 is here and there, so I will also write it. 5 is here and there, I will also write it. And then minus 2 is here but not there, so I just close, and I don't care about the others. I don't need to go and watch what is here and not there. So as far as I start with this one, I check this elements that are both in both of them, I am done. So that is the intersection between these two sets. And there is also a terminology that I want you to know. If the intersection of two sets, for example, if I don't know, for example, if I give you C equals to just square root of 3 and a square root of 2, if I ask you what is the intersection between A and C, of course you immediately see that there is nothing in common between these two sets. So you open the curly brackets, nothing left to put in, and then you close it. So this means that this is the empty set. If the intersection of two sets is empty, we call they are disjoint sets. And that is the definition that I want to mention here. So definition. The sets A and B are said to be disjoint sets if A intersection B is the empty set. So that is just the terminology that I want you to know about this. Okay, for example, let me give you an example of disjoint sets. So I and Q, the famous sets, the set of irrationals and the set of rationals, are disjoint sets. Yes? Why? Because if I intersect I with the rational numbers, by the definition of irrational, we say irrational number is a number which is not rational. So it means that you cannot find something in common between these two sets by the definition of the irrational. So this becomes equal to empty. Okay, I think it's a good point to stop here. But I will also have a theorem like this theorem for intersection. So this theorem, a similar theorem with this, with 9 parts. You can also think about it yourself. For example, the first one would be A intersection with the empty set. What would be the answer this time, you think?
The empty set.
The empty set. For example, the other one would be A intersection with the universal set. What would be the answer?
A.
The set itself, exactly. So I think that's a good exercise to think and write this theorem with 9 parts again, but this time for the intersection operation. And then there are some theorems that are connecting intersection and union in one place. Okay, so one of them is the De Morgan laws. For example, what happens if I want to union two sets and then take the complement? And then distributive laws. So what happens if I have A union with B intersection? We will talk about this after the break. Okay? Okay, any questions?
Babak,
Yes?
can you update the pages we have to do during the break on the school stuff?
Yes, I will try to do that. Yes, I will try to do that.
Okay. And I have another question. Will you give us the definitions of like Q, I, and R in the test? Like rational?
No, these are standard ones. You need to learn it from Math 1C actually.
Okay, yes.
Yeah, so R, it's not hard. So the set of natural numbers, the set of the integers, no, but you need to know them by heart. The only thing that I can give you is the formula sheet, and the formula sheet doesn't contain those definitions, I think. No.
Okay. Have a great Christmas.
Yeah, you too. By the way, I actually was in a hurry. I thought that I don't know, Tuesday was the last day, but now today is the real last day hopefully we go back to normal after the break. So yes, Merry Christmas and Happy New Year. We are 3 weeks actually. The break, I saw it, it is 3 weeks, and that's quite long. So you can have a very good rest.
I'm sure we
So
will.
that I can make trouble for you again after the break, yes. Okay, let me stop this and then say goodbye.